I'm waiting to get my transformers, and I look through some cases I have. It looks to be about 280 millimeters by about 200. And if we double the depth, I'd say by 80. I'm assuming it's a Chinese case. There are no markings on it. And I think I like it because I can move the front or back panel. Let's say the back panel. I may have to trim it. Drops in nicely there. But it does not drop in nicely here. The reason I am anticipating doing this is I think I'm going to use this heat sink. And I think the heat sink's going to be hot, not temperature-wise, electrically hot. So I would like to recess the heat sink in the case a little bit so the fans, which will be here attached to the heatsink, are all inside the enclosure. Just toying with some things I might do. Now this is not the scale. I had to reduce it to fit it on an 8.5 by 11 sheet of paper. But this is the case I intend to use. Front panel, back panel, and the two sides. The case has these little slots in the side of it to accept intermediate panels. I intend to put one right here. I'm going to mount the transistors on the heatsink without an insulator. That will put the heatsink at the unregulated plus voltage, which could be as much as 42 volts. So these will be, although this will be a plastic rear panel, these are going to be non-metallic or insulating standoffs, so that the screws or nuts on the back, I think they'll be pinhead screws, are not at voltage potential. Then I'll mount two fans on this inner partition. I'm going to put some screens on the bottom somewhere so air can flow up through the bottom, through these two fans, around the heatsink, and I have two more screens on the rear panel. I had the heatsink I used for testing the power supply was 150 millimeters long. I had to reduce that to 120 millimeters. In order to fit it in this case. As I do, I make templates for layout of the devices on the heatsink or the front and rear panel. So I'm going to center punch holes here, 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 and here. These 4 holes will be for the standoffs. Standoff here and one below it, standoff here, one below it, the pass transistor here and here, and I'll move the power rectifier from here to here. This is an IEC connector. This is an outline of the heat sink These holes here, 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 and here line up with the holes in the heatsink. As you can see, there, there, and here, here. These 4 holes, there's 8 of them total. And this big hole are mounting holes for these grills. Two of them, air will be flowing this way, exiting the rear panel. The heatsink, of course, is setting underneath the rear panel on standoffs. Here's the heatsink center punched, automatic center punch. So it's a matter of drilling and tapping all of these holes M3. In order to prepare this case to receive components, I'm going to have to take these little standoffs away. I've never used them in any of the cases, and there's so little. These occur both in the upper portion and the bottom portion of the case, and between the two of them they narrow the available room inside, not by much, but a total of probably 6 millimeters. So here's the cooling system, less of course the air intakes. So you have mounted the fans on this intermediate piece here. Now I need to make some notches or dog houses down here for the wiring to exit. And then this, of course, is the heat sink. Once the top cover's on, these will be set back. Here you can see the rear panel. You can't see it, but there's a rectifier here. There's the 2 pass transistors, an IEC connector, insulating standoffs, put the lid on. So here we have the case assembled, and that's what the back of it looks like. I've mounted everything but the meter. I didn't cut the meter out yet. On the front panel, this will be the power switch, amp setting, plus and minus output, voltage setting, and then this will be the output switch. It's going to be on, off in the center, and shorted down below. So I short it so you don't have to short these leads together. Then I can adjust the short circuit limit using the meter. The nice thing about a load switch, forgetting about the ability to short it, is that I can turn the load on and off while the power supply remains on. This power supply, if you remember the circuitry, has a separate control system with its own power supply, rectifier, and filter capacitors. Then there's another transformer, rectifier, filter capacitor system for the output voltage. If you had a fairly light load on this, and you turned the power supply off, it's possible the control system would lose voltage before this system. Now there's bleeders across the filter capacitors and the output, but the bleeders and the current being drawn may not be enough. Once you lose the control voltage, this voltage and current is unpredictable. So we turn the power supply on, adjust it to what we want, then we turn the load on, or energize the load. So with the components mounted on the front panel, we can now evaluate just how good my estimate of the available room is. Of course, this board has to be in here, and probably on some standoffs. I got to stay away from these terminals. Then I have to put some transformers in. And you see what I'm up against now? I need to be very careful not to elevate the board very much, or I'm going to run into those terminals. Here, if I rotate the board, I position it over top of these resistors, which are tight against the board. That allows me to raise the board up like this without running into the lower terminal. Or could I move it here, perhaps? Then I could raise it up. Well, I could raise it up. Sure, I could raise it up there. I have to put a control power transformer in. I could perhaps move it up pretty close to this wall. Then I could position the board symmetrically. Could I? No, I'm going to run into that transformer. Remember, there's two of these transformers. I don't really want to block these fans too tightly. Come on in. Got a little interrupted there. If I scoot this thing over towards the edge of the box, hold these about 8 millimeters off the fans, I can use 10 millimeter standoffs and not get close to this terminal. So I think I'll go that way. So the next thing I have to do is cut these legs off the transformers and take out, like I did these two, the bolts supporting it. I've removed the through bolts on these transformers. And I've installed 8 threaded bolts with nuts standing proud. I mean, there's a nut holding the bolt into the case, but then there's an additional nut here. Transformers will go on like this. And I'll adjust the spacer so that these feet neither touch the bottom nor the top. I decided not to cut the feet off. So this will be the way the transformers sit inside the case. Here we have the transformers again mounted, the board mounted, and the front panel in place. Now, I have this board on standoffs. I'll show you why later. It's awful close here, awfully close, but it's not touching. So I think we've got that. So we'll position this transformer, which should be easy. We've got a lot of room for it. Get this in there. This transformer is fine. Before I cover everything up, I should point out there's 2 air vents. See on the bottom. So the airflow will come in through the fans and out the vents on the end. And that's why I wanted standoffs. See, there's lots of clearance there. I may replace these with whatever the next smaller spacer length is, but there's plenty of room under here. All right, this will be the end of, I think, part 3. I'll call it 3A. I need to cut the front panel here for the meter. I'm holding this up because I had to fit the case together. It's a little heavy, isn't it? Okay. So there's the case fully populated. So part 3B will be wiring of this. Everything's mounted. Grills are on the base of the case. Grills on the back. Fans. 2 power transformers, the control transformer, the board itself.